The ML registry is one of the most important governance mechanisms in Azure ML, and it's tested heavily in D1.2. Let's be precise about what a registry is and isn't. A registry is not inside a workspace. It's a sibling resource. It lives at the same level in the Azure resource hierarchy as a workspace. A registry can be associated with multiple workspaces across your organization, potentially across multiple Azure regions. This is the key difference from workspace-level assets. A model registered in Workspace A is not automatically visible to Workspace B. A model published to a registry is visible to any workspace that the registry is configured to serve. What can you put in a registry? Environments, models, components, and data assets. Essentially, the complete set of ML assets. In practice, registries are most commonly used for three things. Curated company standard environments. One team maintains them, every other team uses them. Validated production models. A model passes evaluation and gets promoted to the registry for consumption by downstream teams. And shared pipeline components, building blocks that data science teams across the organization can assemble into their own pipelines. The CLI syntax is the exam trap here. To publish to a workspace, you use -workspace name. To publish to a registry, you replace that with -registry name. Getting this wrong in production means your model went to the workspace and not the registry, and downstream consumers won't find it. The full name format for consuming a registry asset is the URI Azure ML Registries Models versions. Know this format, the exam puts it in job YAML snippets and asks you to identify what's wrong when a pipeline can't find an asset. For governance, use separate RBAC assignments on the registry versus the workspace. Data scientists get reader on the registry. They can pull assets but not publish. MLOps engineers get contributor. They can publish validated assets after they pass evaluation gates. This separation means no one can self-publish a model to the registry without going through the evaluation pipeline. The registry becomes most powerful when it's integrated into a promotion workflow. This is the pattern the exam tests in scenario questions about MLOps governance. Let's walk through it. The flow starts in the dev workspace. A data scientist trains a model, evaluates it, and the evaluation metrics meet the minimum threshold, say accuracy above 0.85 on the holdout set. At this point, the model is registered in the dev workspace as a workspace asset. But it's not production ready yet. It needs to pass a promotion gate. The promotion gate is implemented in a CI/CD pipeline, either GitHub Actions or Azure DevOps. The pipeline runs when a new model version is registered in the dev workspace. It pulls the evaluation metrics logged to MLflow, checks them against configurable thresholds, and if they pass, it proceeds. If not, it fails the pipeline run and notifies the team. When metrics pass, the pipeline publishes the model to the registry using AZML model create-registry name. At this point, the model is in the registry with a registry version number. Registry versioning is independent from workspace versioning, so the first model promoted to the registry is version 1, regardless of what version it was in the dev workspace. Human approval can be added at this stage, both GitHub Actions and Azure DevOps via deployment gates. Support a manual approval step before the production deployment proceeds. An ML team lead or quality reviewer gets a notification, reviews the metrics dashboard, and approves or rejects. This is the governance pattern for regulated industries, where a human must sign off on every model update. After promotion, the production workspace pulls the model from the registry by its URI. If a production model ever needs to be rolled back, you simply point the endpoint back to the previous registry version. No retraining needed because old versions remain in a registry indefinitely.